So in this session, we'll discuss beta decay. What is a beta decay? So what happened when the nucleus emit out a beta particle? What is a beta particle? The beta particle is actually electron. So electron, when nucleus emit out electron, that is known as the beta particle. But the question arises that in the beginning of the chapter, when we started, we said that when we have an atom consists of the neutron and protons inside the nucleus, and around the nucleus there are electrons. And the source of these all radioactive radiation is the nucleus. So electrons are around the nucleus. When we observe the beta particle is actually an electron coming out from the nucleus. So when the electron is coming out from the nucleus, this electron is known as beta. But the question arises here that how electron can come out from the nucleus if it is not there. Like as you can see that when we draw the nucleus of an atom, we don't draw electron inside the nucleus. But in radioactive emission, we find that the electron is coming out from the nucleus. So the question is how this electron is coming out from the nucleus if it is not there. So answer to this question is actually what happened in a beta decay. One of the neutron which is present in the nucleus break down into proton and electron. So one neutron, as a result, what happened, because there are a lot of particles, it is too much populated, the nucleus is having a lot of particles. So in a beta decay, what happened, one of the neutron breaks into proton and electron, and this electron, when it come out, we call that as a beta. So originally in the beginning, electron is not there, but it is only produced by the neutron and then it is released from the nucleus. So what happened in a beta decay, the nucleon number, which is denoted by A, look, the nucleon number is a sum of neutron and proton. So what happened in a beta decay, a neutron breaks into proton and electron. So neutron number decreases because a neutron break down, so neutron number decreases, but the proton number increases. So the sum will remain same. Like if one neutron decrease, one proton increase, so the addition, the sum will remain same. So the nucleon number during a beta decay, the nucleon number does not change. But what happened to atomic number? Atomic number, which is Z, is also the number of the proton. Due to when one of the neutron change into proton and electron, so proton number increases in the nucleus. As the proton number increases, the atomic number will also increase. So during a beta decay, whenever there is a beta decay, that the proton number will increase because one of the neutrons breaks into proton and electron. So proton number increases, and due to the increase in proton number, atomic number increases. But what happened to nucleon number, the sum of the neutron and proton, that does not change. Why the sum of neutron and proton does not change? Because one of the neutron breaks down into proton and electron, so neutron number decreases, but the proton number increase. So sum will remain same. Like if neutron decrease by 1, proton increases by 1, so the sum of these particles remains same. That's why the nucleon number, there is no change. So in a beta decay is actually the emission of electron from a nucleus of a radioactive element. So when we write the equation for a beta emission, as you can see here, this is a general equation for a beta. The nucleon number, this is a symbol for a beta. You can use E, 0 and -1, or you can also use this symbol for beta, which is 0 and -1. Both ways it is acceptable. So nucleon number, the mass number does not change, and what happened to atomic number? It increases by 1. So a general equation, this is a general equation. This one is an example, as they mentioned here. Like example, there's a beta decay. An element is emitting out beta particles. So what happened to nucleon number? Originally it was 137. It will remain 137. Nucleon number does not change. No change. But what happened to the proton number? Originally it is 55. Now it become 56 because the number of the proton increases by 1. So it will always change by 1, increase by 1. And then there's a symbol for beta. Another example, as you can see, the carbon is there 6 and 12, which is a radioactive. So what happened to nucleon number? There is no change. And what happened to the proton number? It increases by 1. Same way for lead, the nucleon number does not change when it emit out beta. But what happened to the the proton number? It increases by 1. So all the cases, the proton number in a beta emission increases by 1. So example, this isotope of the lithium, like this is the isotope of the lithium, which is having 3 proton. The shaded side are representing the proton, 3 proton, and 1 2 3 4 5 neutrons are there. Using the same representation, so we have to use the same representation. In the space after the arrow, draw a diagram to show the nucleus form and write the name of the particle that is identified as beta. So which particle is a beta? That is electron. Electron is also known as beta. Now we have to show the nucleus. This is the nucleus because the radioactive radiations are emitted out from the nucleus. So we have to show the new nucleus after emitting out beta. Basically what happened in a beta, one of the neutron breaks down into proton and electron. So neutron number should decrease and the proton number should increase. The shaded sides are representing the proton. So originally there are 3 protons. Then now how many protons will be there? It will have 4 protons. So 1, 2, 3, 4. And that is the shaded part. So the proton number increases by 1. And what happened to neutron number? Originally 1, 2, 3, 4, 5 neutrons are there. But out of 5, one of the neutron break down. So how many we are left with? We are left with 4. So 1, 2, 3, 4. So 4 neutrons will be there, 4 protons will be there, and the particle which is released, that is electron. So another example, as we discussed already, that whenever there's a beta emission or a beta decay, the atomic mass does not change and atomic number increases by 1. So one isotope of irradium, which is 194, is represented by 194 IR and 77. This isotope decay by emission of a beta to a stable isotope of platinum. Complete the nuclide notation. So remember, whenever there is a beta decay, the atomic nucleon number, there is no change. So if it is 194, it will remain 194. But what happened to atomic number? Because the proton number increases by 1, so it increases by 1. So originally it is 77, now it will become 78. And what is the symbol for a beta? So this is 0 and -1 because it does not have any nucleon and it is having a charge of -1, or which is same as electron. So another example, the question is state the type of radiation emitted when americium decay into neptunium. So we have to check what is happening. First it is 400, 241, and then it becomes 237. So the nucleon number changes by 4, and 95 become 93. So the proton number changes by 2. So if the nucleon number changes by 4 and a proton number changes by 2, so which kind of radiations are emitted out? So it is emitting out alpha. Because in alpha emission, the nucleon number changes by 4 and the atomic number changes by 2. Then phosphorus decay into silicon. As you can see, the second one, the mass, the nucleon number does not change. Originally it is 32, it remains 32. But 15 becomes 16. So no change in the nucleon number, but the atomic number increases by 1. So which type of emission is this? So this is a beta emission. So whenever there is a beta emission, atomic number atomic number increases by 1 and the nucleon number or the mass number does not change. So iodine 131 and 53 emit out beta particle and turn into xenon. State the number of the particles. So this one will be 53. This will subtract 131 minus 53, so 78, and this is 53. Then we have to write state the symbol and include nuclide in nuclide notation for a xenon. So we have to write an equation here for like basically not equation, we have to show how xenon, but what happened is xenon is formed by emission of the beta particle. So we have first iodine isotope. So iodine is 131 and 53, and it turned into xenon by emitting out a beta particle. So it is emitting out a beta particle. Whenever there is a beta emission, what happened? The nucleon number, there is no change. So if it is 131 before, it will remain 131 after. So xenon will have 131. But what happened to atomic number? Atomic number or the proton number increases by 1, so it will become 54. So we have to write the nuclide notation for xenon only. So the xenon which is formed here, the atomic number will be the nucleon number will be 131 and atomic number will be 54. Another question related to beta emission. Bismuth 214 decay by emitting out a beta particle and convert into polonium. This is a symbol for beta 0 minus 1. So when the new nuclei formed, what happened to the nucleon number? It does not change. Whenever there is a beta decay, there is no change in the nucleon number. So if it is 214, it remained 214. But what happened to the atomic number? The proton number or atomic number, it increases by 1. So originally it is 83, it will turn out to be 84. So this is always the case whenever there is a beta emission. Another question related to beta emission. The hydrogen tritium has 1 proton and 2 neutrons. So what is the nucleon number? 1 proton and 2 neutron. So 1 plus 2, so nucleon number will be 3 and proton number is 1. It emit out beta particle, complete the equation. So beta particle is 0 and minus 1. And we have to, the symbol X represent a nuclide by this decay. So what will be the new element form here, like the substance, the nucleon number of element X? So nucleon number does not change. So it will remain 3. And the atomic number, it increases by 1. So it originally it is 1, 1 plus 1, so it will become 2. So the nucleon number, there is no change, and atomic number increases by 1. So radioactive isotope carbon-14 is there, emit beta particle as a decay. The decay of a carbon-14 produce a nitrogen. State the nature of a beta particle and state where it is produced. So what is the nature of the beta particle? Beta particles are electrons, and all the source of these radiation, alpha, beta and gamma, are produced from the nucleus. So source of these radiation is the nucleus. Even alpha is emitted from the nucleus, beta is emitted from the nucleus, and the gamma, which we'll discuss, will also emitted from the nucleus. So we have to complete this equation. Beta is 0 and -1. The nucleon number, it is 14 for carbon. So nucleon number, when beta emission is there, there is no change. So if it is 14, so it will remain 14. But what happened to atomic number? It increases by 1. So plus 1, 6 plus 1. So it will turn out to be 7. So atomic mass, nucleon number does not change, whereas atomic number increases by 1. So in this question, figure 11.1 shows a data about the 9 elements. Different elements are there. So carbon 14 is a radioactive isotope with a nucleon number of 14, and it decay by emitting out beta. Use any data you need to write down the nuclide notation of this decay. So we have to write down the nuclide notation like the equation for this decay. So in the beginning they mentioned carbon 14. So carbon 14 means nucleon number is 14, and atomic number is the identity of the element. So atomic number does not change, only the nucleon number change for isotope. So carbon 14 will be there, 14 and 6, because carbon atomic number is 6. Then what happened? They mentioned it is emitting out beta. You can write beta first. So if it is emitting out beta, this is a symbol for beta. Then whenever there is a beta emission, what happened to nucleon number? Nucleon number, there will be no change. And what happened to proton number? It increases by 1. So the nucleon number does not change. It will remain 14. And atomic number increases by 1. So 6 plus 1, that will become 7. So which element is having a proton number 7? That is nitrogen. So this will turn out to be nitrogen atom. So figure 10.2 represent a neutral atom of an isotope element X. The isotope of element X is radioactive. Radioactive means it can emit out radiation such as alpha, beta and gamma. It decay to form an isotope Y by emitting out beta. Use the figure 10.1, deduce the nuclide notation for isotope Y produced by this decay. So basically first this is X. X turn into Y. So X turn into Y by emitting out beta particle. That is what happened. So first we have to complete a nuclide notation for X. How many nucleons are there? Nucleon means number of the particle in the nucleus, or sum of neutron and proton. So when we count, so this will be 1, 2, 3, like here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Like here 1, then 4, then 3, then 4, and then 1. So total nucleon, the total number of nucleon are 13. And how many protons are there? The shaded sides are representing proton 1, 2, 3, 4, 5. So there are 5 protons. It is emitting out beta, so beta is 0, -1, that's fixed. Now, whenever there's a beta emission, what happened to nucleon number? There will be no change. And what happened to atomic number? It increases by 1. So if originally it is 13, it will remain 13, but 5 plus 1, it will become 6. So this is a nuclide notation for the emission of beta particle when X turn into Y. Then the last one is the gamma decay. Basically, gamma is an emission. In gamma, it's just the nucleus is emitting out the radiation. There is no change in atomic number, no change in atomic mass. So if it is 240, it will remain 240. If it is 94, it will remain 94. Only it release the energy. So gamma is emission of electromagnetic radiation from the nucleus. Normally, whenever there is alpha decay, it is associated by a gamma emission, or a beta decay also emitted associated with a gamma. So gamma emission or a gamma instead of decay, you can say gamma emission is not causing any change in the atomic number or change in atomic mass. So if we summarize the 3 decays as we discussed the alpha decay, beta, and gamma. So here in alpha, what happened? The nucleon number A decreased by, or you can say nucleon number decreased by 4, and the atomic number or the proton number decreased by 2. Wherein beta, what happens? The nucleon number, the sum of neutron and proton, there is no change. It will remain same. And atomic number will increase by 1. And when there is a gamma emission, the nucleon number remains same, atomic number will also remain same. So there is no change in atomic mass, no change in atomic number.